Today I will elaborate the most important procedure that is applied in the microbiology lab, and that technique the procedure is called the Crohn's staining. There are the three steps for the Crohn's staining. Steps for the Crohn's staining. First of all, we make the smear and then we fix it, and then is the procedure of staining. So smear preparation, fixation, and finally the bronze staining. How we prepare a specimen for bronze staining? First of all, we make the smear. Make the smear. With the help of the wire loop, we take an inoculum from the culture and that is spreaded over a clean glass slide, and this is air dried or it is dried by the heat so that it is fixed to the glass slide. After the fixation, we perform the most important procedure, that is the Crohn's staining. After making the smear, after fixation, then we perform the Crohn's staining. So let us come to the definition of smear. What is the smear? A biological specimen containing bacterial cells is spreaded over a glass slide for microscopic examination. So, what is the smear? Smear is a biological specimen that contains the bacterial cells that is spreaded over a glass slide for the microscopic examination, and this smear may be thick or may be thin. The query arises is that why it is necessary to prepare a thin smear. It is necessary to prepare a smear or a thin smear in order to visualize individual bacterial cells and their morphology. So smear preparation is the first step. The smear is also used. The smear preparation is a procedure that is also used in the hematology as well as the microbiology. In the hematology, there are the two types of the smear, the thin smear and thick smear. While in case of microbiology, we make a smear in a circular way. So the smear is made in hematology as well as in the bacteriology laboratory for the investigations. So this image shows the smear, thin smear, and thin smear, and they are usually performed in the hematology, while the thin smear, while the circular smear is performed in the microbiology for the isolation or the identification of the bacteria. The first step was the smear preparation, and the second step is the fixation. The bacteria are fixed to the glass slides in order to stain them. Without the fixation, the smear that is will be washed off. So it is necessary fix the smear to the glass slide, and the fixation is done by two methods. One is the air dry, or by giving the heat to the glass slide, thus thereby the smear fixed. Now the stain. First step was the smear preparation, second step was the fixation, and third step is the actual base topic, that is the ground staining. So what is a stain? A stain is a dye which is used to color bacterial cells present in a smear. So what is a stain? A stain is a dye which is used to color bacterial cells present in smear, and the process of coloring is called staining. So by definition, staining is an artificial coloration of biological specimen containing microorganisms in order to visualize them under microscope. So in this way, the staining is defined. This is a definition of a stain, and this is the staining procedure. Why it is necessary to stain? It is necessary to stain the bacterial cells because without staining, bacteria cannot be seen because they are transparent and they are colorless and cannot be seen without staining. So there the the wet smear of bacteria is a transparent and colorless, and we are unable to visualize them under microscope until and unless we stain the smear. So it is necessary to stain smear.
Hanno vedut. T'ha veduto dall'altro?
There are the different types of staining. The simple stain means a single stain or single dye is used. Only one stain, only one staining dye is used, and example is the methylene blue. Only this dye is used. Primarily, no secondary dye or the counter staining dye is used. So when this single stain is used, this is called the simple staining. the differential stain when there are the two different dyes used. One is the primary dye and second is the secondary stain. So the primary stain, then the counter stain is by the secondary dye. Primary dye, the primary stain is in case of the bronze staining is the crystal violet, and the secondary stains are the safranin and the melachite green. Mostly the safranin is used in the bronze staining. In the absence of the safranin, we can use the melachite green. And third type of staining is the selective stain. Selective means we stain a particular part of the structure of bacteria. So when a particular structure or the particular part of its bacterial cell is stained, this stain is called the selective stain. And the example are the spore staining or the flagellar stain. So flagella are stained by a specific stain and that is called selective, and spores are also selectively stained. So these are called the selective stain. Now jumping over the grounds stain. What will be the requirements for performing the grounds staining procedure? These are the requirements. We need the specimen, and the specimen may be in the form of any type of the biological material, that may be the pus, cerebrospinal fluid, sputum, or urine. So any type of the biological material may be the specimen. Then this specimen is the smear is made from this specimen on the glass slide with the help of the wire loop. And for the fixation, the Bunsen burner is used. So the specimen, glass slide, wire loop, Bunsen burner, and the different staining dyes, among them the crystal violet, the grounds iodine, and aceton alcohol and safranin. These are the four staining dyes which are used in the grams staining, and the to see the this smear gram staining, we need the light microscope. So these are the requirements. This one is the Bunsen burner for the fixation of the smear. We apply the heat under the glass slides so that the smear can be fixed. And these are the slides, clean glass slides, and this is a wire loop. With the help of this wire loop, we take we take the inoculi from the specimen directly, or from the culture, from the growth. So from the culture or the direct specimen is taken with the help of this wire loop, and the smear is made on the glass slide, and then this glass slide is fixed by the Bunsen burner. Thus the smear is prepared. These are the four staining dyes used. The gram staining. This one is a violet type or the blue type. This is a crystal violet. This is the violet color. So, as the name indicates, it is a violet known as a crystal violet solution. And then the bronze iodine solution is used. And then for decolorization, the alcohol acetone 95% used. And finally, for the counter staining, the safranine solution is used. This is a red. This is a pink or red. This is a violet. And this is the trapping agent which helps in trapping the crystal violet within the bacteria. And this is a decolorizer. So these are the four you should remember the which are the stains or the dyes used in the gram staining. These are the four dyes used in the gram staining. What is the purpose of gram staining? The purpose of the aim of the gram staining is to identify the bacteria, and this also helps in the antibiotic selection. The gram staining also helps in the gram stain selection in the way that the gram positive bacteria, they are sensitive to the penicillins, while the gram negative bacteria, they are resistant to the penicillins. So we guess, we predict that the which type of the antibiotic is selected for the gram positive or gram negative bacteria. So this helps in the selection of antibiotics, and this also helps in identification bacteria. The those bacteria which are stained by crystal violet and are not decolorized, they are gram positive. The gram positive bacteria, they are stained by the crystal violet, and the on the decolorization they are not decolorized. They remain violet, they remain blue. So the gram positive bacteria. So the gram positive bacteria, gram positive bacteria appear to be violet or blue, and the bacteria which are decolorized with the decolorized and need the counter staining such as the safranine, they are gram negative bacteria, and the color of the safranine dye is pink or red. So the gram negative bacteria, they are pink, and gram positive bacteria, they are the purple, blue or violet. So this is the principle. Now coming to the steps or the procedure. The smear is prepared and that is fixed by heat. Step 1. Step 2. The slide is covered with the crystal violet and left for 1 minute. Step 3. Then the grams iodine is applied and let it is left for 1 minute. Then the decolorizer aceton alcohol is applied for few seconds, and the then the counter-staining dye, that is the safrani or the milashide green or the neutral red, is applied as a counter stain for 2 minutes. And now the stain is completed, the gram staining is completed, and we leave the slide to become dry, and finally we wash it under we wash the under surface of the slide and dry it, and then we examine under the microscope. So the principle of the staining technique: when the primary stain crystal violet is applied, the all the bacteria, either the gram negative or gram positive, they become the purple or the violet. And then the grams iodine, second step, the grams iodine is used as a mordant. Mordant means the trapping agent that fixes the dye, that fixes the crystal violet, and it becomes a strong crystal violet complex. Still, the color of both gram positive and gram negative is the purple. Now, when the third step, we apply the decolorizing agent. In case of the when we apply the decolorizing agent, that is the aceton alcohol, if the bacteria are gram negative, they lose their color, but the gram positive bacteria, they remain purple. They retain their color. If they are the gram negative bacteria, they will lose the color, and now when they lose the color, they become the transparent. We cannot see them. Now we use the counter stain, that is the safrani, for realize the gram negative bacteria, and they become the red or pink. So gram negative bacteria, they are pink, and gram positive bacteria, they are purple. Results: the gram positive bacteria, they seem to be purple. Gram negative bacteria, they look like pink red, and you can see the pus cells, the neutrophils, the pus cells, and you can uh, you can see the epithelial cells, and you can see the yeast cells. So these are the results. The gram positive bacteria, purple, gram negative pink, and you also write down the pus cells if you see, and their number of the pus cells, and how many epithelial cells they are seen. You write down in the number, and also the yeast cells. These are the fungi cells. looking at the result, as you know, the gram positive bacteria, they are purple. They may be in the form of bacilli, cocci, and so they are the purple, and they may be in the form of cocci or bacilli. On the right side, the bacteria are pink or red, so they are gram negative bacteria. Thanks for listening. This was the today's topic, and that was the Grom's study. Thank you very much.